Good day, everyone. Today we will discuss an important substructure construction technique called piling. Pile foundations are deep foundations used when the surface soil is too weak to safely support a structure. Instead of transferring the building load through shallow foundations, piles transfer the load to stronger soil or rock at greater depths. Pile foundations are widely used in high-rise buildings, bridges, ports, offshore structures, and industrial projects where heavy loads are involved. In today's lecture, we will understand the functions of piles, their types, pile driving methods, and commonly used piling techniques. A pile is a long, slender structural member that transfers loads from a structure to deeper, stronger soil layers or rock. Piles may be precast or cast in situ. Depending on project requirements, they can be made of timber, reinforced concrete, steel, or composite materials. Pile foundations are generally adopted when the loose or compressible soil extends to a great depth and shallow foundations become unsuitable. The load from the structure is transferred either through the tip of the pile, known as end-bearing action, or through skin friction developed along the sides of the pile. Sometimes, both mechanisms work together to support the load. Pile foundations perform several important functions. They transfer vertical loads from buildings to stronger soil layers below. They also resist horizontal forces caused by wind, earthquakes, and water currents. In offshore structures such as jetties and bridges, piles transfer loads through water into the underlying soil. Pile foundations also help reduce excessive settlement and improve the bearing capacity of weak soils. Based on the load transfer mechanism, piles are classified into two major types. The first is the end-bearing pile, where the load is transferred directly to hard rock or a strong bearing layer at the pile tip. The second is the friction pile, where the load is transferred mainly through friction developed between the pile surface and the surrounding soil. Based on pile driving method, piling is classified into displacement pile and replacement pile. Displacement pile is further classified into precast concrete piles and preformed steel piles. Also, replacement pile is classified into bored cast in situ pile, partially preformed pile, and grout/concrete intruded pile. The selection of a suitable installation method depends on several factors, including soil type, groundwater level, pile dimensions, noise restrictions, and nearby structures. In urban areas where vibration must be minimized, bored piling is generally preferred. On the other hand, driven piles are suitable, where dense soils require displacement for improved bearing capacity. Precast concrete piles are further classified as RCC piles of full length, jointed RCC piles, and hollow tubular section piles. Also, preformed steel pile is classified into H-section, box section, and tubular section piles. Now let us discuss the common methods used for installing piles. The first method is impact driving, where repeated hammer blows drive the pile into the ground. The second method involves forming a borehole, inserting reinforcement, and filling it with concrete. This is known as cast in situ piling. The third method is vibratory driving, where vibrations reduce soil resistance and allow the pile to penetrate easily. This method is effective in non-cohesive soils. The final method is jacking, where piles are pressed into the ground using hydraulic jacks. This technique is especially useful near existing buildings because it produces very little noise and vibration. Impact pile driving is one of the oldest and most widely used methods of pile installation. A hammer repeatedly strikes the pile head, transferring dynamic energy that drives the pile into the ground. The basic sequence includes installing the pile driver, transporting the pile, lifting and positioning the pile, driving the pile until the required depth or resistance is achieved. Depending on the equipment, impact hammers may be drop hammers, single-acting hammers, double-acting hammers, or diesel hammers. Although impact driving is efficient, it produces significant noise and vibration, making it unsuitable near sensitive structures. Several piling techniques are used depending on the project requirements. These include rotary board piling, continuous flight auger piling, tripod board piling, dropping weight hammer, vibratory piling, jacking method. Each method has its own advantages and is selected based on soil conditions, pile diameter, depth, accessibility, and environmental constraints. We will see techniques in detail. Rotary board piling is one of the most widely used modern piling techniques. A borehole is drilled using an auger, drilling bucket, or core barrel. Temporary casing is often installed to prevent the sides of the borehole from collapsing. Once the required depth is reached, the reinforcement cage is lowered into the borehole, and concrete is poured using a tremie pipe. Finally, the temporary casing is removed for reuse. The rotary board piles have diameters ranging from 600 to 2,400 millimeters in depths, up to 50 meters. These piles are suitable for both soft and hard ground conditions and produce very little noise and vibration. This diagram illustrates the process of rotary board piling, showing the steps from setting up the rig and drilling, to inserting the reinforcement, pouring the concrete, and retracting the casing. We will look into the applications and advantages of rotary board piling. Rotary board piles are suitable for constructing secant pile walls and contiguous pile walls, which are commonly used for deep excavations and basement construction. These piles can also penetrate hard rock and layered rock formations, making them suitable for large infrastructure projects. Another important application is construction near roads, railways, and existing buildings, where vibration must be minimized. One of the biggest advantages of this method is that it generates very little noise and vibration, making it ideal for urban construction. Another advantage is that the equipment can drill through a wide variety of soil and rock conditions without changing the basic drilling system. The next piling technique is continuous flight auger, commonly known as CFA piling. In this method, a continuous auger drills the soil to the required depth. Unlike conventional board piling, the auger has a hollow stem. After reaching the design depth, high slump concrete is pumped through the hollow stem, while the auger is slowly withdrawn. Immediately after concreting, the reinforcement cage is inserted into the fresh concrete. The CFA piles generally have diameters ranging from 150 mm to 1,300 mm in depths up to 30 meters. The major advantage is that the borehole remains stable because concrete is placed immediately after drilling. Let us see the applications and advantages of CFA piling. CFA piles are mainly used for foundation piles in soft ground, secant pile walls, contiguous pile walls, soldier pile walls used in excavation support. One major advantage is that no drill casing is required, reducing both equipment and construction time. Another advantage is that the entire drilling operation is completed without changing drilling tools, increasing productivity. Since there is very little vibration and noise, CFA piling is suitable for projects located in urban areas. The tripod board piling method is one of the most widely used piling techniques in India. A tripod supports a heavy chisel, which repeatedly breaks the soil. A winch lifts and drops the chisel during drilling. Temporary casing pipes prevent the borehole from collapsing. A bentonite slurry tank circulates drilling fluid, which stabilizes the borehole and carries excavated soil to the surface. The tripod board piles generally have diameters between 150 mm and 600 mm and depths up to 30 meters. Although this method is slower than rotary piling, it remains economical for small and medium-sized projects. The tripod board piling method is mainly used in soft soils, especially when mud circulation is adopted. An important advantage is that it can be used in restricted access areas, where large piling machines cannot enter. Most components of the tripod rig can be assembled and handled manually, making the equipment economical for smaller projects. Although the construction speed is comparatively lower, this method continues to be widely adopted in India because of its simplicity and low initial investment. Now let us discuss the dropping weight hammer method. This is one of the oldest methods used for driving displacement piles. A heavy hammer, weighing approximately half the weight of the pile, is lifted and allowed to fall freely onto the pile head. Repeated hammer blows gradually drive the pile into the ground. In a single-acting hammer, compressed air lifts the hammer while gravity provides the downward force. In a double-acting hammer, compressed air acts during both upward and downward movement, increasing driving speed. Diesel hammers generate impact energy using combustion inside the hammer cylinder. The vibratory piling method is mainly used for non-cohesive soils, such as sand and gravel. A vibratory hammer attached to the pile head generates high-frequency vibrations, usually between 20 and 40 Hz. These vibrations reduce friction between the pile surface and surrounding soil, allowing the pile to penetrate more easily. Although this method is very fast, it has certain disadvantages. Continuous vibration may cause settlement of nearby buildings, generate excessive noise, and affect sensitive equipment. Therefore, engineers carefully evaluate surrounding structures before selecting this method. The final piling technique discussed in this lecture is the jacking method of insertion. Instead of using hammer blows, hydraulic jacks apply a continuous downward force to push the pile into the ground. The reaction force is obtained from the existing structure or a specially designed reaction frame. Since no hammering is involved, this method produces almost no vibration and very little noise. For this reason, jacked piles are commonly used for underpinning existing buildings and strengthening old foundations. It is particularly useful in congested urban areas where vibration could damage nearby buildings. Let us recap. Pile foundations are deep foundations used when upper soil layers cannot safely support structural loads. We discussed functions of piles and learned that loads can be transferred either through end bearing, skin friction, or combination of both. We studied pile installation methods, including rotary board piling, continuous flight auger piling, tripod board piling, dropping weight hammer, vibratory piling, jacking method. Among these methods, rotary board piling and CFA piling are most commonly used in modern urban construction. As future civil engineers, selecting correct piling technique based on soil conditions, load requirements, construction constraints, and environmental considerations is essential for ensuring safe and economical foundation design. Thank you.